The discovery of electrons started the great atomic age. In 1896, Peter Zeeman performed an experiment that seemed too simple to be revolutionary. He placed a salt flame between the poles of a magnet and viewed it through a spectroscope. The single line of light from the flame split into multiple, distinct lines. It was a clue that something fundamental was happening. A magnetic field, which acts only on moving charged particles, was affecting the light. This meant the light wasn't coming from the atom as a whole. It was being emitted by something inside the atom, a particle carrying a charge. Zeeman had stumbled upon the first concrete evidence for the electron, a particle so small and mysterious that his mentor, Hendrik Lorentz, had only theorized about it. This one simple observation opened the door to the atomic age, proving the atom was not the smallest unit of matter, but made up of tiny charged particles, a discovery so profound that it earned Peter a Nobel Prize in physics.
Peter Zeeman was born in 1865 in Sonemeyer, a quiet town in the Netherlands. His father was the headmaster of the local school. He attended his father's school in Sonemeyer, where he quickly stood out for his curiosity and precision. When a spectacular aurora lit up the Dutch sky in 1883, young Peter submitted a detailed report to the scientific journal Nature, an extraordinary achievement for an 18-year-old from a small village. That moment marked his debut in the scientific world. After high school, Peter passed his exams to study at the prestigious University of Leiden in 1885. At Leiden, Zeeman came under the mentorship of Hendrik Lorentz, one of the great physicists of his time, a relationship that would prove crucial to both their careers. To understand Zeeman's discovery, we need to know that every atom, when excited by heat or electricity, emits light of a specific color depending on its wavelengths. These spectral lines arising from electrons jumping between energy levels are unique for each element, just like our fingerprints. In 1896, Peter Zeeman heated sodium atoms in a flame and studied their spectrum through his spectroscopus. Normally, sodium produces two characteristic bright yellow lines. But when Zeeman placed those atoms in a strong magnetic field, something extraordinary happened. Each single line split into several closely spaced lines. The splitting of spectral lines in the presence of a magnetic field. But why did this happen? The answer revealed something revolutionary. Magnetic fields only act on moving electric charges. If light from atoms changed under a magnetic field, it meant something inside the atom carried electric charge and was in motion. That something, soon identified as the electron, was direct proof of Hendrik Lorentz's daring electron theory. This remarkable phenomenon became known as the Zeeman Effect. The implications were staggering. Suddenly, the atom wasn't a solid, indivisible sphere, as classical physics claimed. It contained smaller, charged particles that could be influenced by external forces. The Zeeman effect became the foundation of countless modern technologies. MRI machines map the human body using magnetic field effects on atomic nuclei. GPS satellites rely on precise atomic clocks, calibrated using the principles Zeeman discovered. Astronomers measure magnetic fields on the sun and distant stars by analyzing the splitting patterns of spectral lines, reading the magnetic fingerprints of atoms across the cosmos. From plasma research fueling nuclear fusion experiments to the delicate manipulations required for quantum computing, we are still building our technological future on the foundations Zeeman laid in 1896. Every solar flare we predict, every quantum bit we manipulate, every magnetic sensor we deploy, it all traces back to his simple observation of split light.
In 1902, Peter Zeeman and Hendrik Lorentz were jointly awarded the Nobel Prize in Physics for their research into the influence of magnetism on radiation phenomena. Zeeman was just 37 years old. The Nobel Committee praised it as a magnificent synthesis of theory and experiment. Together, their work not only confirmed the existence of the electron, but completely reshaped our understanding of atomic structure and the fundamental nature of matter. In 1900, Zeeman was appointed professor of physics at the University of Amsterdam. By 1908, he succeeded van der Waals as full professor, and in 1923 became the first director of the newly established Zeeman Laboratory, which still bears his name today. Throughout his distinguished career, he received numerous international honors: the Rumford Medal, the Matteucci Medal, and election to the Royal Netherlands Academy of Arts and Sciences, among others. He continued his research and teaching until his retirement in 1935, remaining intellectually active until his final days. On October 9, 1943, during the dark years of World War II, Peter Zeeman passed away in Nazi-occupied Netherlands. Yet his scientific legacy remained untouched, his name forever etched in the annals of physics. The Zeeman Effect lives on as more than just a scientific principle. It's a constant reminder that the most profound discoveries often come from the simplest observations. Peter Zeeman split a line of light, and in doing so, split open our understanding of the atom itself, forever changing how humanity perceives the building blocks of reality. This is Awards, where the world's greatest minds live forever. Don't just watch history, be inspired by it.
Thanks for being with Awards. Subscribe to know more about international award winners and unsung heroes behind peace, science, and humanity.